should be going live in just a minute.
Okay. Got you up.
Got the fancy music going. Yeah, the stream was going to be about malware. Now it's going to be about how the new Mountain Dew was terrible.
We're gonna have to find a way to plug that in.
Uh, this episode is not brought to you by the new Mountain Dew. Guess I should test this real quick. All right. Good evening, people. This is the first episode in a series on intro to malware analysis that we're going to try to get out there and just have a little fun with. I've got Iron Beagle with me today, who's just going to be in here to keep me company more than anything. Tonight we're going to be going over things like setting up your machines to create a small lab environment to test the malware in. And we'll start with some, after that, we'll start with some basic static analysis of a live sample. So, let's go ahead and get started with that. 1 second. Alright, so the first machine that I go to is Remnix, which can be downloaded from remnix.org. I will throw that in the chat just so anybody has access to it. And
So I guess I'll start shooting off some questions here. Why Remnix?
somebody took the time to develop it. Lenny Zeltzer took the time to develop it, and it's just a very, very all-inclusive toolkit that nobody else has been quite as comprehensive that I have found to make a distribution with all of the tools you might possibly need. There's always going to be a tool or something missing, but at least with these, you can see 95% of what you would need is already built in.
Very cool.
So, I mean, it's got everything from Ghidra to Python scripts that will help you throughout your investigation. So, why don't you get Remnix downloaded and put it into a virtual machine? You're going to want to check the configuration. And go ahead and get your ENS33 IP address from there and take note of it somewhere. Write it down, put it somewhere, because we're going to need it once we start setting up the other VM. On the other side, we're going to want to have a Windows workstation to be able to run malware on and start testing it, because, you know, everybody's going to need some sort of, you know, fun bait target. For this, I've still got distribution that's not available to the public, but there is a very good one in Flare VM. I've actually pulled some of the Flare VM tools onto here because I think Flare VM set up extremely well. I just happened to have this one, and I really liked it, so I just added what I was missing.
Now, when you're setting up your virtual environments, is there a way to keep them maintained throughout, or do you just blow them up after you're done and then rebuild again?
I go ahead and set up snapshots. So these are both on a clean snapshot. If you look, let's see there. And it's always going to have one that's named good config. That was the day I set them up on this laptop. It's going to be the same with this one. But yeah, I can always revert back to the good config unless something goes horribly, horribly wrong, in which case I just wipe them and start over, because I don't store anything directly on either of these. So,
Right, you don't want to. I'm assuming you don't want a repository of malware.
no, not sitting on these. Yeah, I also keep a folder that I just like to call Danger Zone, because, you know, I was an 80s baby, and yes, Top Gun was a thing.
Of course.
Yeah. So it always reminds me of that and makes me laugh, and, you know, it's good to laugh when you're working, right? So, yeah, so we do that. All right, once you get into your Windows, which I recommend Flare for anybody getting started, into that machine, you're going to want to make sure that both of your settings on your network are going to be, let's see, where are you? Settings, there we go. That the network adapter is going to be host only. The only two machines I want talking to each other are Remnix and the Flare VM. I don't want it talking to my computer. I don't want it talking to the internet. I don't want it talking anywhere. With that, I built a shortcut to get to the network connections, so I can quickly change this. But I want to go into properties and the IPv4, and you'll notice that I have it set up to its DNS server as the end gateway is the Remnix machine, which the 192.168.81.129. That way, all my traffic can be routed through this machine, which will come in handy later, especially when we start dynamic analysis and we start running like tests and start running the malware and seeing what C2 servers it runs looks for. We can get Wireshark captures. We can see the network traffic through INetSim or other tools that we're going to be discussing later. But that's a basic setup. If anybody has any questions, they are welcome to reach out to me on Twitter at Lost0x01. I will be happy to answer any questions that anybody has in that format. So let's get into what is the fun part. Tonight's going to be a very, very short class because there's just not a whole lot to go over on the setup side, because really we basically just want two machines that can only talk to each other, and that's about it. So I did go and pull a sample today for a executable that is known to be malicious. So we'll go ahead and clear that and go over to it. So it's going to be the 739 zip. So unzip. And the password is the same password as almost everything from VX Underground. It is infected. So
just one more time for those that didn't get it.
It is infected. And if you offer to donate to them, they don't take it well, especially if you try to donate and say, so I can get the password. They really don't like that. So, yeah, if you want to have some fun, go for it. But all right, so now we have the long string of what is the malware sample. I'm going to go ahead and rename it to full that would help. That is a tired mistake there.
I mean, eventually you want to get rid of the malware, so
yeah, just not right this second. Yeah, that's called being up too long and not sleeping enough over the past 2 weeks. All right, so now I have that, and I'm guessing that it's an exe. I happen to know that it's an exe, so I was able to name it. But how would you know? So right now we can do. We'll start with file. So we see that it's a P32 executable for Windows. We can also go a little deeper and run a program called TRID on it, which is going to be a just stronger version of file, and it'll break apart what it sees within it. So we see that it's a Windows 64 executable with a possible DOS execution, and generic Windows DOS executable is the highest matches. So that's great. But I think everybody's wanting to know what the malware does. Well, there's a way you can kind of get an idea of what its capabilities are. A little bit earlier than going through and just trying to break it down to the code level, and that's by running a command called a program called Kappa, which has become one of my favorite programs to run, or my favorite things to run early in an investigation, just because it gives me an idea of what I'm looking for. It may not be 100% correct, but at least it will give me some idea. So the nice thing is it's going to come up with your file name, your hashes. It's going to tell you what, it's going to map the tactics to the attack framework. So we're going to see defensive evasions, so they're going to modify the registry and obfuscate the files. There's going to be file and directory discovery and system information discovery. It's going to share modules, and it's also going to boot or log on auto start. So it's going to go ahead and change the registry to set up an auto start, and that's going to be its persistence mechanism. We can come in here and we can see that it's got C2 communication. It is communicating over DNS and HTTP and socket. There is a cryptographic hash. There is the encrypt and decrypt data inside. There's definitely some obfuscated files or information. And we know that it's going to create registry keys, delete registry keys, open registry keys, and set registry keys. So this is just a nice way to kind of go through, see kind of what it does, and like some more of its capabilities is, query a remote server, check HTTP status code. Sorry, can't talk some days. Initialize hashing via WinCrypt. So we're going to look at for hashing stuff. It's going to start looking for files and getting file permissions. It's also going to be able to create and terminate processes, and it's going to be able to delete registry values. So that's kind of a nice way to go look at it.
Yeah. So in a way, you're just kind of building a mind map of what you're going to be drilling down to.
Yep.
What you're going to be looking for, right? Because I mean, eventually you're going to be building detections as well,
Yes.
or needing to build detections with the analysis.
Yeah. No. I
Cool.
mean, it's always trying to find the best way to get to something, and what that is not always immediately obvious, but we usually can get somewhere. The funny thing about malware analysis is you're not always going to find out exactly what you've got, but you should always be able to figure out what it can do. So the next thing that I like to run is strings with the tag A on it, because we should start seeing some wide strings, and we're going to get a lot. And let's actually just run that again and pipe it to more. Alright, so we know that it is a executable program based off the basic headers, and we're going to see all the garbage for a minute, and at some point we should start seeing stuff that's human readable. So we got to the calendar core exit process, so we're starting to see some of the things, and we see that it's dropping a config file, because we can see the brb config.temp. So we know to look for that, because that's going to be something that it drops, and it's probably going to drop it in a temp folder just based off what the name is. We also know this is a BRB bot sample because it names itself more than once.
So, without knowing that this is malware, if it's just like a suspicious executable, how do you know like what's what's suspicious and what's normal?
Well, that's where capabilities come, or the kappa comes in. Is that kind of gives me an idea of what kind of communication and what its abilities are. So I typically want to go in, and if it's something that's suspicious, I'm going to start with the fact that it's probably not good, but I'm not going to say that 100% until I can get a little more information. But when I come in and I see certain things within the file, like with Kappa, we saw the C2 communication, and we saw the obfuscation techniques, and then the persistence mechanisms. So that's going to start telling me that this is probably malicious. And then strings starts to give me more of an idea of what it can do. It'll start telling me what libraries are imported with like the ntdll.dll and the advapi32.dll. Then we're also going to see, hey, it's starting to set registry values and open registry keys and delete values and flush keys and close them, and connection, like open and close internet connections to make sure that it can run. This one's going to try to open this. It's also going to try to look at the app data and go to this registry to see if what can be run through registry keys. This one, another one I like to look out for is the cryptography ones. Like, is this trying to encrypt itself or decrypt itself within while being run, which we'll see more of that later. Heap create. But yeah, so we're just starting to get an idea. We're seeing kind of what it does now, because we can kind of put together what we're seeing based off what processes it's running. So now we can actually take it over here to the Windows machine.
I guess it depends also too. Like if you have a suspicious file that is supposed to be a PDF converter, and you start seeing a lot of network connections or
Yeah, I should see no network
APIs for
connection.
network,
Yeah.
right? That kind of adds
Yeah.
to the this is not what it's supposed to be.
So the next tool that I like to go to on the Windows machine is PE Studio. This is basically does a lot of what we just did, but just starts to give me levels of what it is. So we know that this file contains another file. We know, the obviously, level 3 is not, level 3s and 4s are not very important. Level 2s are starting to get a little questionable. And then level 1 is like, okay, this is suspicious. But we can also go over here and look at the imports. So we know what it's importing from the libraries, and we know what libraries it's using. We can go back and see all the strings. The cool thing about the strings thing here is I can sort them, and all the blacklist strings are the ones that kind of give me an idea if it's malicious or not. And yes, there are legitimate uses for them, but we're trying to figure out if it's malicious or not, and does it match what we should be seeing based off what we're told the file was. So this is just a quick way to kind of do that. So let's say it was sent over as a PDF viewer or PDF editor. There's no reason it should be changing the registry. There's no reason for it to have network things unless it's for updating, and then it should have to be started within the program, not on its own. The cryptography, we start to get into why are we creating hashes and encrypting and destroying keys, and why does it need to be able to create processes, terminate processes, and things like that. So we look for things that shouldn't be there. It should be able to move a file and delete a file and get a temporary file name, because that's going to be part of what it does when it goes to open files. So we start to look for that. Why would it have a user agent for the internet if it was just a PDF? There's no point in that. But it's, again, you just start to see things, and the more you do it, the better you get at it, and it becomes more and more fun. So from here, there's a couple directions we can go. We've got a pretty good idea of what we're doing with a file. We know that it is malicious, and one thing we can do is take it into a program like a debugger. So let's do this and drag it. And we remember that it was a 32-bit executable because of the stuff we saw earlier. And hopefully this will load. If not, open.
So in a way, it kind of seems like, a good practice would be, obviously safely downloading samples of, malware.
Yeah.
But it seems like you could also just analyze normal, safe.
Oh yeah, absolutely. And it's good to analyze safe things too, because then you know what you should be expecting, not just what,
Yeah.
If you only look at bad, everything looks bad.
Yeah.
So yeah, I've done that where I've gone actually for work, where they've sent over a program that a user requested to be installed, and it wasn't on our safe list, so they had me reverse engineer that just to make sure that it fell in line with what it was supposed to be.
Yeah.
So you can get practice on this anyway, man. Anything you download, you can go and have fun with it. So I'm gonna extract this to desktop real quick. Try to figure out why it's being difficult. Okay. That's why. So we are going to go change the name of it. Actually, I have another sample of it. We'll just grab it from where I know I have a sample that works. So basically, it doesn't want to open. Let's see.
I think I kind of asked the question while you were transitioning over to this. What are you running right now?
So this is going to be X32 debug, which is part of the X64 debug program. And basically, it's just a debugger that will hopefully open at some point. Oh, there it goes. I didn't give it enough time. So what it does is this allows me to step through the program and kind of see what it does, which gets really fun when you get to like some of the encryption data, because you can actually watch the data decrypt in front of you and see what it starts calling to from where it was obfuscated. There's some other really fun things we can do. Which, hold on 1 second for me. Okay, so I'm going back over to the other machine because what I was saying was PE Studio is just a nice GUI version, but on the Remnix machine you also have this, which is called PE Frame. And it will also analyze the file, give you the same kind of information. We can see, what it's doing with the file. So it's pulling these libraries, it's creating a temp file here. So that's kind of what we're looking for. And this should load up in just a second. There we go. So here we can go and see the file name, what it is. We can get hashes. We can see if I don't have it connected to the internet, but if you do, you can get it, the virus total link and what it scores it. We can see the entry point of it. We can see more hashes. And we can see the sections of it to see how they're doing it. And we can also see the features. So we see that it does have mutex, it does have an anti-debug, it does have a packer, which is why it's probably not opening in X32 debug is because of the anti-debug, and it is a pack software. We can see some of the behavior. So we see anti-debug, XOR, network HTTP, screenshot. So now we know it takes screenshots as well. And that we see that it was packed in Microsoft Visual CPP 80. The mutex it's changing is the wait. Let's scroll up a little bit. Wait for single object. So it's going to be doing things to try to read if it's already been installed on the system. So it's going to wait for this one object to come through, and if it sees that object, it knows it's already been installed, and it won't install again. Anti-debug is debugger present. That's always a clear one. If the debugger is present, it's going to terminate the process. There are ways around this error. I just have to go set it up again in a second. And then we know that there are some suspicious sections in the .text section of the file. So, and
what are those, like, next to that text portion there? What are those numbers? What do they represent?
It's a size.
Okay.
On this one, it's a size, and on import function, those numbers are how many times it's called. So I think that's going to be 6.34 kilobytes, I believe. It's not big. It may be meg, but it's not big at all. And then we get into all the strings and libraries we saw, and we're back to the end of that. So let's go back over here. I'm going to open this. Maybe. Options. Preferences. System breakpoint and exit breakpoint. So what I'm doing is basically turning this on to that way, instead of exiting when we run it and just causing the debugger not to work, it should allow us to load it. And then we can go to plugins, and I can go to Scylla Hide and options. And we can do that one. And basically just click everything down the left side of this one. And this will basically keep it from... should allow it to open up this time. But it's not. Something's breaking. You know, always happens when you go live.
It knows.
It knows. I have analyzed this thing like 100 times. I'm going to try it from here. Just a second. All
So
right.
because
so
we started
broken.
off with with Remnux.
Yeah. There we go.
Like, is that because it's just kind of easier to? Oh, there we go. Easier to start doing like your.
It gives me a very quick amount of information, and it gives me the opportunity to go yay or nay pretty much really quickly.
Yep.
I'm more comfortable in a Linux environment. Other people are more comfortable in a Windows environment. It's just kind of what you get used to, and neither way is wrong. It's just it is entirely a preference.
Yep.
As to what you want to do. So let's see. So now as we get this in, we're starting to get into this. We're definitely not going to go over this part tonight and the calls and things like that, but I wanted to at least get it seen. Because you can see it gets a little confusing to read. But you'll start to see as we go into it. This will probably be week 3 or week 4 that we really break this one down this way. Next week we'll be doing the dynamic analysis of it and actually running the malware and pretty much blowing up our machine and going through all the things we can go through that way, which will probably take 2 weeks to do. Just because I am limiting this to a smaller time frame. Only because I can tell you, after watching 4 and 5 hours of malware analysis videos, you really forget what you learn very quickly. So I'm going to try to do these in smaller 30-minute segments.
As with everything.
Yeah. So, again, thanks, Iron, for coming. This is a really good stopping place because we at least see that we've got things working. We know kind of why we're using Remnux and things like that. And we'll start breaking down more and more of the processes, and the dynamic comes next week, which will be really fun because we will be launching that and just going ahead and, running it and setting up several different processes in place to monitor the activity. And that's the next step in what we would do. There are other options too, like if you have, I didn't do this today, but one of the tools I also like to use is the Hybrid Analysis Sandbox. You can go there, drop a file in that you're not sure of, and get a sandbox report back very quickly, and decide whether it's one you want to dig into more, or if they gave you enough right off the bat. So that's just a way to streamline some of the work. And as you get busy, and it's great to learn how to do all of this manually, but there comes a time where you can't do every single piece of malware you see. So you want to save time for the interesting ones. So, thanks everybody. And yes, Mark, Windows is absolutely wrong. So, Awesome. Well, have a great night. I appreciate everybody coming, and I will hopefully get this back up by next Wednesday, and we'll start with the dynamic analysis at 9 o'clock next Wednesday. All right. Thank you.